Hello everybody and welcome to Season 1 Episode 4 of Electronics and Alcohol. Today I'm going to work on cradle to grave type build, which consists of us putting together a mainboard, daughterboard, and then a temperature daughterboard with a light sensor coupled to it. And to do that we've got my design that I put together, and what we'll do is we'll solder it from beginning to end, all three boards, and then we'll do testing, which consists of using the Arduino set of tools, and then after that doing a little bit of coding, and then putting it on my test bench, powering it up, loading up the software, and then going into Cayenne and building a dashboard to control. We're going to do a relay, temperature sensor, and then we're going to do a light sensor. The temperature sensor is a DS18B20, which is a Dallas sensor. It's all digital. And then we've got a photo sensor cell, which is a pen or ADC pen on the ESP-12F. And then we've got a standard one-piece 5-volt relay that is actuated by GPIO 4. And then once we do that, I'll show you the code and give you a good overview of what I ran into. Now this video is really into a response of some of the reaction that I got when I first started doing the Arduino builds. Now I originally started doing Cayenne because I was doing the coding myself. I wasn't using ESP Easy, I wasn't using MCU Hub, Node MCU, I wasn't using any of these. I was just coding, hard coding the chips. So what I did is one night I ran into basically a wall, then came back the next day and then figured it out. And what I did is I started with the Raspberry Pi. I had the newer one, and started building off of it, and I had a ton of sensors on it, which it was working great. And I was like, you know, I could do better than this. So what I did is I went back to the drawing board and I started using the ESP-07s. And when I started doing that, I wanted to see if I could use the ESP-07 on the Cayenne MQTT system. And I was running into a lot of roadblocks. And what I was doing is I was using the, I think it was the Mini Duo boards, Arduino uploads to get the stuff to work. And once again, I started hard coding and I started getting the programming down to where I could actually get it to work. Well, never did work too well. It came to the point where when I started doing the actual temperature sensors and the light sensors, it was reading 32 degrees Fahrenheit, which I thought was 32 degrees Celsius, and it wasn't. So this video will be in a response to that, because now I have succeeded, and according to the forums, there's not a lot of, the ones I've read, there's not a lot of good information on exactly how to do it. There's no granularity to it. It's very high level. People are saying, well, you got to do this and this, depends on your situation. Well, not me. What I'm going to do is I'm going to put this together, I'm going to show you how it works, and I'm going to show the code to you so you can build off of it. Yeah, there's probably going to be a situation where you actually want to put a different type of sensor on there. Not a problem. That's when you actually have to dive into the code. Now, I have to put a caveat in this because I have coded this, and it's been a few years since it's done some fucking code. The code's probably not perfect. It's probably heavy, and it's probably redundant, but it's a starting point. After this, I'll go back and I'll start fine-tuning the code so there isn't as much gibber. So there'll be minimal lines of code, so the ESP-8266 has more memory for future upgrades or features, but that's a caveat. So once we do that, anybody should be able to set up Cayenne on an ESP-8266 using the Arduino Uno platform in Cayenne. It's basically an emulation for the ESP-8266, as I like to see it, and operate it as a standard Arduino platform, Raspberry Pi platform, without it being without a big difference. So let's go ahead and start. We'll go ahead and start building on the board. So before we start, we need to finish this mainboard, and then we'll go ahead and start on the ESP-8266 panel, which I have take a look right here, see what we got. So it's another motherboard. I'm going to dig through all these damn components here. Ah, there's one. So this is the ESP-8266. This is version F motherboard or daughterboard. So this will basically mount in this slot right here. So to do that, we've got most of the stuff completed. We've got 5-volt pinouts here for accessories. We've got a 5-pin rail here for GPIO pinouts. Then I have another 5 rail here, and these are 10, basically 10 outputs. On each side, the 5 volts plus and minus is always on the left, and it's always plus top minus bottom. And I kind of configured that to where the additional components that we have, for instance, I don't have any built right now, but for instance, this is a automatic fan controller board, and it works off of a thermistor and a 500K varistor, which goes right there. And I'm using an LM741 as the main control, which I have on order. I haven't gotten those yet, so this board is to be built. We also have, let's see which else we're going to get here. Simple one. This is an adjustable one, but it's not automatic. So what you can do is you can adjust the, there's another potentiometer, or not potentiometer, but varistor that goes here, pot varistor, and then MPN. You got an optocoupler PC817, and then a diode. LED indicators stating if the fan's on or not. But you can adjust this one for temperature, and then it's turned on and off by a GPIO pin, which is operated off of the optocoupler through the NPN. So that board is pretty much done. So this is the motherboard, as I like to call it, for the main piece of all these small components that I have. And it works well with the F. The only problem is I can't use pin GPIO 9, the MOSI MISO, because that's part of the memory connections that are inside of the actual ESP-8266. But it's a fully functional board, and it's based off some of the other designs that I put together, which seem to work really well. So that is the motherboard. We'll go to the daughter boards here in a second. So we're back at the old station. I'm going to go ahead and start working on this ESP-8266 7/12EF daughter board. And to do that, we're going to use, out of my assortment here, just got some new 12Es in. Don't use that one. We'll use that one. Looks pretty clean. Run into a lot of duds on the 7, and which is kind of disappointing because I really like the 7 because of the external antenna connection. So we need 11x2 pin out at a 90-degree angle. So we'll go ahead and pull out 2 pin 90. All kinds of these here. Let's go ahead and cut that. Go ahead and cut that. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. We'll cut that out like that. So, and then we've got a 3.3 regulator, which is part of the board. I don't like to mix the onboard motherboard regulator with the ones that are actually on the daughter boards. That makes it to where if you need external power, you can actually plug it in to an additional transformer, or you can use the actual daughter board on something else, which has its own onboard regulation. So the next thing I've got is you notice on the top of it, it's TX-RX ground 5 volt. That's basically for the FTDI connection to program the actual board. So that is going to be a 9-degree 1 pin by 4 pin 90 degree that goes up here. I mix this stuff up in my own lab, man. So 90 degree 1 pin. So I'll take this out. Take this, cut it 4. Now I've got 4 breakouts for it, but I don't use them. The reason being is this, in most cases, if you wanted to, you could connect up 5 volts to the actual pinout as well. But I do not do that because the motherboard contains the switch for the let's see, contains the switch and the reset button, and you need those things for programming. If you don't have them, it won't work. So next thing, we flip the board over. By the way, these are 2-layer PCBs, and I've got an array of 1604 type resistor spots and 1604 type capacitor spots. So in this case, what I need, I'm gonna have to go to the drawing. It's a multitude of them. I've got 2 capacitors that are 47 microfarads, and then I've got 2 1Ks, I think a 2K and a 4K7. The 4K7 is for light, which is analog, and that's to measure lux. So now that we've got most of them, let's go ahead and start on the main piece of the board. Now what I usually do is I start from the middle and work my way out, depending on how the difficulty is on each of the components. So this one isn't too bad, so we'll go ahead and start with the actual ESP. So far, so good. So once this is finished, I'm going to go ahead and pin this out, and I'll get the resistors on the back. I know it's boring. And then once we do that, we'll go ahead and do a test. Alright, now that we've got most of the components on here, what I'm going to do is I'm going to go ahead and do the 22 pin, the 11 by 2 pin out that connects the daughter board to the motherboard first. But it is what it is. Alright, let's go ahead and finish this up. So like I've had problems before, let's go ahead and solder one of these pins on here just to make sure it's aligned. And there you have daughterboard motherboard, with daughterboard being the controller, the ESP-07 controller that outfits all of these pen placements for GPIO connectivity. Now initially this will not be connected to 240 volts because I do not like to have open high voltage on my desk, just for the fact that you could electrocute yourself. So this will be tested on a 5-volt bench supply and then programmed as accordingly through Arduino. And then we'll go ahead and configure the Cayenne to read the ESP-12 and go from there. So now that we got the main board put together, we got the daughterboard put together for the controller, we're going to go ahead and put together a photocell sensor or light sensor and a temperature sensor board. This board connects to GPIO 10 on the 12F, which even though it's part of the memory chip, it still works well. So what I'm doing now is I'm getting my parts together, and I'm going to force 4700 ohm. Alright, so this board is done. So what I can do is I can show you exactly how this thing mounts up, and it sits backwards in the slot. So the temperature sensor can be pointed up. Now, like I said before, this board system is going to be updated due to the fact that it's really close to this 2x5 pin set. So now we have a temperature sensor and we have a light sensor hooked up to that. So now that we're done with the board, we're going to go ahead and go to the Cayenne desktop and start configuring this. Alright, now that we've got pretty much everything in order, what we're going to go ahead and do is we're going to start assembling the package, and then we're going to go ahead and flash the ESP-12 to get it running. So to do that, let's go ahead and start assembling this. And as you know, that's pretty much plug and play. Really simple. What I'm using is a USB FTDI connector, which is really easy to use, and it's a lot easier than having to use you know, the Arduino Unos, because it's just, I love these things to death. They're really good for breakout, but when it comes to doing stuff that just requires a simple FTDI, this is the best way to go. So the FTDI cable is basically USB broken out, and it's got a chip inside of the actual connector to the USB port. This one is transmit, receive, and then ground. Those are the only three that I need to plug in here because we're going to get power from our external power supply that's on our bench. So we'll go ahead and fire that up. Now we want to make sure is the switch here is on program. So when we go to our serial connector or serial monitor, we notice it now, and I preloaded it. we've got data flowing. We don't want that. What we want to do is we want to make sure that this thing is stationary. So let's go ahead and switch our switch, and then we hit the button. Once it does that, at the bottom of the actual serial window, it stops. And that means now it's ready to go ahead and take a load. So if you look at the configuration, and we'll go through this briefly, the includes that I used for this initially entailed the Cayenne defines the Blink Simple ESP-8266, the Wi-Fi client. For the Dallas temperature sensor, it's the one wire, and then the Dallas temperature includes. What I did after that is I added these three at the top, which is ESP-8266 Wi-Fi, the client, and then the client secure. Client secure is for encryption as secure socket layers if you need to connect a client to the device itself. Now, constant integer, the temporary pin is 10. This is used for the Dallas temperature sensor. I'm using GPIO 10 on the actual ESP-12F itself. The sensor pin, which is the light photocell, is A0, which is analog 0. Now, when you put this in here and you try to put analog 1, it won't work because the software it recognizes only that one input. Float light level. This is just for the calculation floating alphanumeric float that we use to insert for calculations. Here's my token, my character token. This is actually from given to you from the guys at Cayenne. And that's I'll show you that briefly as well. SSID and password, of course, and then here's the one wire. Here's the Dallas temperature sensor stuff. This is the initialization program that pulls up the temp pin as GPIO 10, and then Dallas temperature sensors. It's the one wire. So the one wire is actually a sub call from the Dallas temperature sensor, and it's telling you which pin to pull the data from. So as we go into the setup void. Usually people put 9600 in the serial begin. I don't, because sometimes the data flows so fast that 9600 can't keep up with it. Yeah, granted, I probably can't read it when it's going even 9600, but I don't want to bottleneck anything. And using the fastest speed, it doesn't hurt anything. It doesn't slow it down. It doesn't crash it. So here I've set my pin modes. Now these are the actual GPIO pins that are on the 12F board. So 10 is set to output, A0 is set to input. Now if you noticed, I did not put the pin out for the relay that we're going to put on there. And I didn't need to, because once you start using the Cayenne software, you can actually select it within the settings once the relay is built on the website, and I'll show you that as well. So there's no need to put it hard coding in there for it. So within the loop, we've got the light level, which is one of the variables that we put in the front, and then analog read A0. So that actually reads the ADC pin or A0 pin on the 12F. I put the serial print line in here to show the light level inside of the serial screen or the serial monitor screen, just to show me what was being read on the chip. And then the delay. If you don't put a delay in there, it goes nuts. And then the Cayenne run, which is common, that's just to start the actual the software on the device. Now here is the Cayenne out. This is actually feeding the light level, which is pinned out here, that reads off of A0 and feeds it to virtual port 3. And that's within the software of Cayenne, and I'll show you that as well. Also in Cayenne out, I've got another call, Cayenne out V2, and this is requesting a temperature sensor, which is the Dallas sensor. You can either do F, which is Fahrenheit, or you can do C, which is Celsius, and you just tab these out or slash them out as comments if you don't want to use one or the other. Just make sure that you don't have the sensor's request temperature on there. commented out, because then it will not work at all. And that's it. That's the whole gist of the program. So once we do that, we do a test verify, and it's compiling. Today's drink, by the way, is Bacardi Black with Diet Coke Lime. About a half a shot. It's really good. So I'm not sure why this is taking so long to compile. And it's done. So we found out that the compiling actually went through. We can now, since our 12F is still in standby mode for software load, we'll just go ahead and upload it. The upload's very small, but it takes the same amount of time for anything. There is no speed adjustment on the uploading to the flash. I think it's because the flash can only take a certain speed. So, 2/3 of the way done. Alright, so it's connecting to my Wi-Fi. It calls ArduinoMyDevices.com, which is the Cayenne website. And then it starts spitting out all kinds of information. Now that we've got that rolling, let's go ahead and set up our sensors on the board, which I already have. Great God. So like I said before, we've got a relay, we've got a temperature sensor, we've got a light sensor. So the temperature sensor, according to this board and it's set up to GPIO 10 on the ESP-12F, which does not interfere with the onboard memory. Great thing. GPIO 9, that's a problem. So your relay here, you've got 5 volts AC or 5 volts DC, plus minus, and then I've got GPIO 4 hooked up into this. So we'll go back to the bench. Let's go ahead and pull up. Let's see here. Let's pull up Cayenne. So we're on the Arduino Uno. So we want to add a new device. Add device widget. So let's first do. Let's do the relay first. So it's a relay switch. We'll say main relay Arduino Uno, because it's feeding off of that actual board call out, I guess you'd say, connectivity. It's a digital connection. It's either on or off. So pen D10, choose widget, we'll do button. And if you want to, you can look at the sketch file. This basically defines what it is. I don't use it because I don't need it. And there's your on-off relay portion of it. So we'll close that. So then we'll add, choose icon. Sorry about that. So let's choose a light, and then we add the actuator. So we got that connected up. So let's verify all of our connections here. Integrated GPIO, which means it's actually calling out the pin on the the ESP826612F. Invert logic means you can either do off to on to off. We can do that. So let's go ahead and save. So let's go ahead and test it. Not getting a warm and fuzzy on this one. I made a mistake. It's not channel 10, it's channel 4. People do make mistakes, especially when they're drinking Bacardi Black and Diet Coke. So there it goes. So as you see, DW41, as it climbs up the corporate ladder, if you would, that means it's pin 4, digital right, pin 4, on, and then off. Digital 4, digital right, 4, off. Alright, so we got the relay done. Now we've got 2 more sensors that we have to implement. Now we'll go ahead and do that. Device widget, sensors, temperature. There's our DS18B20. It's a virtual pen. The virtual pen for this one is V2. If you look, temp pen 10, and then the actual subcommand is V2. So Cayenne now is actually feeding virtual pen 2, even though it says temp pen is temporary pen is 10. I'm not using it. And of course, this is just to set it to output. So we'll do that. Value, we need to choose an icon, do thermometer, and sketch file. Of course, we can look at that. So if you notice in the actual sketch, it actually does the include calls, which is one wire and Dallas temperature. It's doing the same thing I just did in the actual coding. It's calling out virtual pen as V1, and then there's your character token, which is called out for Cayenne, and then the rest of the. Now here's something that you really have to remember. This Celsius right does not work. This Fahrenheit right does not work. What you have to do, if you look at the code that I wrote, and I read this in a forum somewhere, I'll post it in the comments down below. Virtual write. Now the reason you have to put virtual write is because you're not writing to an actual GPIO pen. You're writing to a virtual pen. Now, I can't count the times that I was going through banging my head against the wall trying to figure out how to fucking get this thing to work. Well, I finally got somebody that had posted in a forum, and I think it was on Cayenne. They went ahead and put that in there, and I thought to myself, it was for a different sensor. It wasn't for this sensor. I thought to myself, why would he want to put virtual? And I was thinking, because it may have been a virtual pen, and then the light bulb came on, so I said, I'll give it a shot. When I did that, it worked. A lot of people have been having problems getting these DS18B20s to interface with the ESP-8266 through Cayenne. This is the result, and it is a positive result. I have gotten it to work. So let's go back to our Cayenne and set it up. Done. So we've got all of these things set up, and let's add the sensor. So let's make sure our virtual channels are all set up. Virtual channel, save. So 73.5 or 73.7. So what I'm going to do is I'm going to go over here and take my nitty-gritty fingers, and I'm going to pinch it. Climb, you bad boy. There it goes. So that being done is telling me that the actual sensor is working. So that problem's solved. And this is also on the Fahrenheit and the Celsius. Now here's another one. Here's another caveat for you. Make sure if you're using Celsius that you comment out, you take the commenting out of this for this line of code, and do not use this one. So Celsius, make sure you're using Celsius. And here, make sure you're using Fahrenheit or Celsius and correspond it to each other. Don't put Fahrenheit here and Celsius here. It gives you a whacked out calculation and it doesn't work. You'll never get the right. It'll fluctuate. It'll show movement, but it won't be right. Alright, so the third and last and most complicated one that has busted my ass for the last, I can't count how many times or how many months, weeks, days, is the light controller. So we go to luminosity, we go to photoresistor. I've got this set up on Virtual Pen 3, as we saw in the code, Cayenne out V3. It's giving the pen V3 the light level. So we'll go here, Virtual Pen V3, choose value, that'll be a gauge, and then we'll add the sensor. This one will max out to 1024, as it always does. Now, once we pinch it and block out most of the light, it should drop. Which it's not. So then we got to turn some light off. There it goes. If you know the serial monitor, it started to drop. These things are really sensitive, and I'm wondering if 10K is too much, because 10 kilo ohm pull down resistor is drowning it down to the point where the sensor is it's ultra sensitive. I had to turn off all my lights to get the thing down to like 500 lumens. So just by doing that, it tells us that the actual photosensor is working. Now the question is do we use a 10K, or do we use a 4.7K, or do we use a 2K? I think it's all a matter of what application you're using it for. But that is basically a rundown of the Cayenne desktop environment using both the DS18B20, a photoresistor, and a main relay. I hope this has helped a lot of people in the community, because in the past I've had a lot of problems, and this was one of my biggest ones. I'm not an expert. Yeah, I might be an electronics guru and whatnot in some aspects, but this was kicking my ass. So I finally broke down and said I'm going to fix it. So if you liked the video, go ahead and select like down below, and happy making, and we'll see you next time.